Hello my dear students, how are you all? Welcome to Deeksha Karnataka YouTube channel. Today I am here with another session of Masterstroke for Continuity and Differentiability, right? So again, it's a very high-weighted chapter for your PU2. We have to do it properly, we have to do thoroughly. So I'm going to discuss all the concepts and we'll also solve bacha total of 5 questions today to bridge the concepts and problems together, right? So I hope you're ready for that. I hope you're excited for that. So let's solve all these questions and learn the concepts as well, revise all these concepts as well. I have already taught you this in very detail in the KCET series, okay? If you are somebody who wants to watch the detailed session, so topic wise it's discussed bacha right over there, go ahead, check the playlist out. But if you're here just to revise with me, just to prepare, brush up all the concepts with me, this is your session. So please, let's start with the session right away. What we have, sir? What do we have? First thing is continuity. Okay, so when can we call a given function fx continuous? Okay, so continuity of a function at a point. Whenever bacha we can say, let's say for a function given at function fx, we are checking the continuity bacha at the point x equals to a. Okay, at x equals to a. Whenever we can say that limit of the function fx when x tends to a becomes equals to f of a, then the function will be called continuous. Then the function will be called continuous. So first you have to find the limit and then check for whether it is the value coming for the limit is equal to the function value at that point or not. Okay, how do you find limits, sir? Of course you'll have both approach. You have to find bacha both LHL and RHL, both LHL and RHL. So find that, check for the limit. Okay, they should be both equal to each other, then only we can say limit exists, right? We have learned that in PU1. So that should be equal to the f of a value. That is the continuity of a function at a point. The point where the function is continuous is called the point of continuity, right? Correct? No? That's what it is. Moving on, sir. Yes, bacha, the session will be a little fast tracked. We'll do the important topics, important points quickly and then move on to solve the questions, right? So let's check bacha for the discontinuity what we have. If the function fx is not continuous at x equals to a, then we simply call this point to be, this function to be discontinuous at that particular point. Okay, and that's how it is said. The discontinuity of a function fx may be due to any of the following reason. What is that, sir? The limit is defined both. What is this called, sir? What is this called, bacha? This is called as LHL. This is our RHL. Okay, so this part or both may not exist. Okay, the limit, as I said for continuity, what should happen? The limit should exist and that should be equal to the function value at a, right? But there can be a case where the LHL is not existing, only LHL, sir, not existing. In that case, what will happen? Will the limit exist, sir? No. There will be a case where RHL is not existing. Means the function does not have a right hand limit at that particular given point. Okay. Then we'll say, sir, again limit does not exist or both cannot exist. Either of the cases, either LHL does not exist or RHL does not exist or both may not exist. Any of the case, bacha, you will say the function is not continuous. The function is not continuous, so simply discontinuous. Agreed? Okay. Next point, bacha, this is done. Limit. This both exist but not equal. How do we define, sir, functions limit exist? When we say LHL exists, RHL also exists. Okay, and they should be both equal. They only say the limit exists, right? So they're saying that if you have this exist, this also exists, but they are not equal to each other, it means, bacha, what? Limit does not exist. It means what, sir? That implies limit does not exist. Limit does not exist. So even second point will be a reason for discontinuity. Okay, next what, sir? Limit fx, same thing, both exist and are equal but not equal to the function value at a, sir. Means what they are saying is limit exists but not equal to f of a. Limit exists but not equal to f of a. Even this case can be reason of discontinuity, can be a reason of discontinuity. So we have 3 reasons, bacha. First reason is, I'll repeat, limit does not exist means, sir, the way can be LHL is not existing or RHL is not existing. Or second, bacha, both LHL and RHL exist but not equal to each other. It means again limit does not exist. Last case, sir, limit exists but not equal to f of a. So continuous function has only one definition. Limit should exist and should be equal to f of a. That's what. Okay, chaliye. So this is the reason for discontinuity, bacha. Now what we have? Algebra of continuity. Algebra of continuity means, yes, if I have a function f and g which is both continuous at the point x equals to a, then f plus g is continuous at x equals to a, that is sum will also be continuous. Okay, same over here, bacha. Difference will also be continuous, sir, at the same point. Product will also be continuous, bacha. Product will also continuous at the same point x equals to A, sir. Okay, and the quotient f by g, right? F by g will also be continuous, provided what, sir? This cannot be 0. This g cannot be 0. G of A should not be equal to 0. Why, sir? It will become undefined, right? For that reason, g of A has to be non-zero. We have mentioned over here. Please check. Again, you can get these notes, bacha, just joining the WhatsApp channel. If you have already joined, you'll get this thing to deliver to you in the WhatsApp channel. So please go ahead and download from there. Okay. If you have somebody who is watching the session for the first time, I'll let you know the notes of all the sessions is delivered in the WhatsApp channel. Once you join it, things are available for you. Okay. So please go ahead and join the WhatsApp channel. The link will be given in the description of this video. Okay. Kf is a continuous function. Again, bacha, if you're multiplying with k, no, this will also be continuous at the point x equals to a. Okay. Now note, sir, if f and g are real functions such that fog is defined, means this is there, bacha. Fog is defined, sir, and g is continuous at x equals to a. How comes, sir, g? Because, bacha, we are writing about f of g of a, no, fog of a, right? So g should be continuous at a and f should be continuous at g, a. I'll repeat, g should be continuous at a and f should be continuous at g of a. Then we can say fog is continuous. Check this out. F is continuous at g of a, then we say fog is continuous at x equals to a. First thing is g continuous at a. Second thing is f should be continuous at g of a. Then what we can say? That fog is continuous at the point x equals to a. I hope this is clear, right? Chaliye. So I don't need these markings. I'll just erase this for you so that you'll have a relevant things to read from. It'll become more neat, right? So please go ahead and check the link out to download your sessions PDF. Let's move on now to continuity in an interval. Okay, when can we say, bacha, whatever interval we have, sir, two types of interval. Interval number one is open interval. Second number is closed interval. In open interval, no problem, sir. Every point in the interval function should be continuous. Then we can say the given function is continuous in the entire interval a comma b. I'll show you. Open interval, sir, here, bacha. Continuity of a function in an open interval is defined like this. Is said to be continuous in an open interval if it is continuous at every point in the interval a comma b. What about continuity in a closed interval, sir? This is simple. Bacha, this has to be for a closed interval, no? This has to be there. This part has to be. So f should be continuous in the open interval a comma b. That has to be there. And bacha, limit should be existing and should be equal to the f of a value. What is the meaning of that, sir? Think about it. I have a comma b, right? A comma b. How can I plot this, bacha? Number line. Think, sir. Let's say this is a here, this is b here. So what they're trying to say, no? The limit value should be existing from this side, no? For a. Will you have, bacha, from left side? Will you have from left side, sir? No, right? Because this is not part of the domain, is it? No. Only this is the part of domain, right? Hence, the RHL should exist. The RHL should exist and should be equal to, bacha, f of a. That is the requisite for a function to be continuous in a closed interval. Are you getting my point? Yes? Okay, sir. So this is called as, bacha, RHL should be equal to f of a. Same, bacha, this is called as LHL, okay, at this point. Means we'll approach this way, no? So LHL over here should be equal to f of a. Means RHL at the point a should be equal to function value at a. And over here, bacha, LHL at this point b should be equal to, bacha, f of b, no? Forgive me, f of b, sir. Function value at that b. Okay, that's how you define a function to be continuous in a closed interval a comma b. Open interval should be there plus these two conditions. Open interval should be there and then these two conditions. Clear, right? So I think this will be relevant to you. I'll erase some extra things. Okay. All right. So I'll just erase these parts. Chali. So now, sir, let's move on to next thing. Some knowledge hub. We are back into knowledge hub. K hub is your knowledge hub. What is it? First thing, sir, function fx is said to be continuous if it is continuous at each point of a domain. Sir, domain why, sir? Of course, when you're defining a function, there will be a domain and range. So if you're calling that function to be continuous, only true if it is continuous in all the point of domain. Agreed? Okay, sir. Chaliye. Think about it, sir. I write here fx equals to 1 by x. Continuous or not? Continuous, sir, because at x equal to 0, it's only discontinuous. The function is, bacha, only discontinuous like this, right? This is the function, no? 1 by x. This is how the function is. Okay. If you increase the value of x, what will happen? The y will keep decreasing. Right? Same goes on the negative side. That's your function. Now do one thing. I'm telling you what. So the only point of discontinuity is, bacha, x equal to 0. Okay. Is that part of domain? No, sir. Hence, that is not relevant. No, sir. Okay, so this has to be only thing which has to be mentioned over here is domain. If the given function is continuous in its domain, then it will be simply what do you call continuous. For example, GIF not continuous bacha, because it has a break in every integers. Okay, is integers part of domain? Of course it is, right? But not part of the, if you check this out, it will become discontinuous if you draw the graph. What I'm talking about, GIF, greater than this function. Check this out. This function, sir, when I'm talking about this, no, okay, this function has open intervals at these points, right? So not continuous at the integral points. Is the integer part of domain? Yes, it is. Integer is part of domain, but is still not continuous. Hence, this will be not be continuous in its domain. Okay, chaliye. Great, sir. I hope you understood this part, right? I hope you understood from these examples. Okay, if you not, let me know in the comment section that you have a doubt. Okay, a function which is continuous at entire real line is said to be continuous everywhere. Of course, no, real line is bacha all real. So continuous everywhere for all real numbers. Okay, next what, sir? A function fx is said to be discontinuous at an open interval if it is on an interval if it is discontinuous at any point. Correct, no? Let's say I take this interval a to b. At any point in the interval, if it is discontinuous, sir, then bacha function f will be discontinuous in this interval. As simple as that. It should be continuous at every single point. Then only we can call this the function to be continuous in that interval. Otherwise, no. Okay, chaliye. What else I have? The set of all points at which the function is continuous is said to be its domain of continuity. Correct, sir? Okay. Simple points, okay? Not very difficult things to understand, but very, very relevant to us. Now we have types of discontinuity. In that we have, if you learned that, okay, removable and non-removable type of discontinuity. Removable and non-removable type of discontinuity, bacha. So we have learned one thing already. Reasons of discontinuity, sir. Reasons of discontinuity, sir. Okay, over here I've given you homework also. Why homework, sir? Because I've taught you this question in my regular sessions. Okay, that's right, I shouldn't have said that, but yes, it is. This is your homework, sir. You have to solve this question after I teach you this concept, but you have to solve this. Okay, so reasons I've already taught you, it was given few slides back, so I'm not going to teach you this part right now. I said no, limit does not exist, limit exists but not equal, all those conditions. Okay, that's the reason. So we'll see what is out of which the reason of the discontinuity, which is called as removable and non-removable type. Okay, where we can call removable and non-removable type. Please check. The first one, bacha, is our removable type of discontinuity. What is it? If the limit, what is that called, sir? L1, the LHL, this, sir, L2, the RHL, they are equal. What means, bacha? It means very simple, sir. Limits, a limit exists because they are saying that L1 is equal to L2. Okay, basically the LHL equals to RHL. LHL equals to RHL. Okay, it is what a limit exists. Okay, whenever we have this but not equal to function value at that point, then this type of function is called as, bacha, this type of discontinuity is called as, is discontinuous only, right? Yes, and this type of discontinuity is called as removable type of discontinuity. We can remove the discontinuity, that's why it's called as removable type of discontinuity. Okay, is known as the removable discontinuity because fx, how do we remove the discontinuity, bacha? How do we remove discontinuity, sir? By defining fx. Okay, by defining fx again at that given point. Okay, by redefining the fx at the point x equals to a such that limit becomes equals to fx. Got it? So what I do for that, first of all, whenever we have limit exist but not equal to function value, that is called as removable type of discontinuity. How do we solve that? How do we remove this discontinuity? Is defining the function again at the given point a. Okay, and then you can do bacha what? Again you will prove this limit will be equal to f of x. This is your homework, please solve it. Okay, chaliye. Non-removable, sir, when limit does not exist. Whenever we have limit does not exist, we can't solve that. No, limit does not exist, bacha. This cannot be, this function cannot, be defined only. Okay, so limit does not exist. Okay, when that case is there, we can say the function is of having non-removable type of discontinuity. Non-removable type of discontinuity. Okay, chaliye. Okay, of first kind. Second kind, bacha, non-removable discontinuity of second kind will be this one. If either limit or both does not exist, this type of discontinuity is said to be non-removable discontinuity of second kind. Okay, means either of them. Means over here limit is existing but not equal. This is also called as limit does not exist. And here, sir, LHL, they are saying, bacha, LHL or RHL does not exist. Here difference is there. Here bacha LHL exists, RHL exists but not equal to each other. What is the result? Limit does not exist. Okay. What about this, sir? Again same thing bacha. Limit does not exist. How come, sir? Because for limit to exist, we should have LHL and RHL should exist and should be equal to each other. Here it exists but not equal. LHL exists, RHL exists but not equal, hence limit does not exist. Same here bacha. LHL or RHL does not exist. In that case also we have limit does not exist. I hope this is clear, not confusing whatsoever. These two are called bacha non-removable types of discontinuity. Okay, chaliye. Now we have some question number 1. Let's solve this question. What we have is find the values of a so that the function f is defined by fx equals to this thing is continuous at x equal to 0. Okay, let's do it. What are you gonna do, sir? Limit can be found from here. Okay, and then f of 0 is what bacha? F of 0 is 1. Okay, we're looking for the value of a, right? Value of a, right? Okay, so we have to apply the limit for this part. Check here. You can apply, sir, limit sine square ax divided by x square. Okay, when x tends to, sir, 0. Correct? No, that's how you find the limit. Okay, let's do one thing. Multiply here bacha with a square, and over here also, sir, with a square. Is that okay? Can you do that? I can do that. No, multiplying and divide by the same number will not change anything. Okay, now we can take this common constant outside. It will become, sir, a square over here. Limit x tends to 0. Okay, what I have is sine square ax by ax the whole square. Now you can see the answer, right? Okay, so a square limit x tends to 0. What I have, sir? Sine ax by ax the whole square. Right now, and what is this going to be, bacha? This is simply going to be a square into 1. So my limit value is coming as a square into 1. This is my bacha limit value. Right now, the limit value is coming as a square into 1. How much is that? Simply a square, sir. Okay, now you put that equal to f of 0. We know that limit should be equal to, sir, f of a, hai na? So we get a square should be equal to, sir, 1. No, f of a is, or f of 0 is 1, right? Okay, so I get a equals to plus minus 1. Plus minus 1. Option C is correct. Please check. Please let me know if you're getting a different answer. I hope this is what you're getting. Okay, if you're doubt, let me know that as well. Question number 1 is done. Moving on to next part, sir, differentiability. Differentiability. Again, bacha, in the first section, the definitions are very, very important. Please go through all these things that I've given you in the session. Download the session's PDF and revise it thoroughly. Questions keeps coming on this as well. Okay, high weightage chapter. What we have here, differentiability of a function at a point. Okay, how do we define bacha differentiability? Simple way. In limits, in continuity we had limit should exist, should be equal to the function's value. Okay, at that point. In bacha differentiability, what should be there? One approach is graphical approach. If you can see the graph of the function, good. Check for the corner points. If you have a corner point, no sharp corners, that will be non-differentiable point. Okay, I'll repeat myself. If you have a corner point in the function, for example, mod of x at x equals to 0. This is a corner point, no? Sharp corner. Then function is non-differentiable at this point. At this point x equal to 0. Okay, so differentiability will be not there at this particular point. So look for that. If you can see the graphical approach. In the algebraic approach, what is there, sir? You have to find bacha LHD and RHD, left hand derivative and right hand derivative, and prove that they're equal to each other. When you can do that, it'll become differentiable. Okay. So what is there? Differentiability of a function at a point. Let fx be a real valued function defined on an open interval. Okay, and c is between the from this interval. Okay, then fx is said to be differentiable or derivable if the limit exists. Okay, finitely, and thus limit is called as the derivative or differential coefficient. Of course, correct? No, LH. What is it, bacha? This limits L1 is actually called as LHD, okay, and this limit L2 is called as RHD. Left hand derivative, right hand derivative. left hand derivative and right hand derivative, and when they become equal to each other, they call what picture? Limit exists. That's what they're saying simply here, limit exists. Okay, but you have to use this approach. And how you do that? How do you find, sir, LHD and RHD? You take here, it will become, I'll show you for LHD, it will become f of a minus h minus f of a, okay, divided by minus h, where h tends to, limit h tends to 0. That's your LHD expression, bacha. This is expression for LHD. Okay, f of a minus h minus fa upon minus h. Same goes with RHD, will become plus over here, it will become plus h. Okay, a plus h upon, this will become bacha plus here, and this will become also plus. Okay, got it? Chaliye. So if you want, I can write it over here for you. So RHD will be simply given by f of a plus h minus f of a, okay, divided by h. Limit again will be there, limit h tends to 0. H tends to 0, sir. Okay, a function is said to be differentiable function if it is differentiable at every point in its domain. Same thing I have explained to you in the case of continuity also. Please go ahead, okay, and learn these things, go through these things, okay, where I've taught you that in detail, bacha, in your sessions for KCET. If you still need to, put more efforts into it, do that. I will certainly recommend you that. Reason being, high weightage chapter, you can't ignore it. That's why. Okay, now we can move on with, as I said, I've already written the expression for this, bacha, but I can write it over here again for you. So for a function to be, for fx to be differentiable, okay, for differentiable, what should happen? We should have LHD should be equal to RHD. Basically, the limit should exist. What they've given here, okay, what we have given here, this limit should exist. How, sir? So same thing I'll write over here. I've already written that, but LHD bacha will be turning out to be limit f of a minus h minus f of a divided by, divided by minus h tends to 0. This is LHD, sir. And for RHD bacha will have, check this out, what will have, sir? Same limit but with plus h minus f of a upon h tends to 0. Okay, means on the right side of the value h will have, this is the condition, a plus, right? This is a plus, this is a minus. Please check. This is a plus, no, sorry, a minus, right? And this is a plus. Then bacha will call what? We'll call, sir, fx is differentiable at x equals to a, when this is true. Got it? Simple enough. Let's move on now. Okay, now we have something more to learn in Knowledge Hub. What is that? If a function is, very important to us, bacha. What is it, sir? If a function fx is differentiable at a point, then it is also continuous. Understand this. Continuity, after continuity only, there can be a question of differentiability. If a function is not continuous, if I have, say, if a function fx is discontinuous, bacha, then simply it will be non-differentiable also. It will be non-differentiable as well. This is very important. Okay, so function to be differentiable, it has to be continuous first. Okay, so let's read the points again. A function fx is differentiable at a point, then it has to be continuous. Differentiable means it has to be continuous, bacha. Next point, sir. If a function fx is not differentiable at a point, then it may or may not be continuous at that point. Again, right? If function is not differentiable, right? Not differentiable, bacha, then it can be continuous also, no? For example, f of x equals to mod of x at x equals to 0. Continuous? Yes. Differentiable? No. So a function is not differentiable, but it can be continuous as well. It can be continuous as well. Okay. It can be discontinuous also, but it can be continuous as well. So option 2 is clear. Option 3 now, if a function fx is continuous at a point, then it may or may not be. Correct, na? Continuous and not differentiable. Okay. Next, sir, if a function fx is discontinuous, then it will be, what will happen, bacha? It will be non-differentiable. What is the example for this? Same thing. I explain right now. This one, not continuous and non-differentiable. Over here, at these points, bacha, what will happen? The function is not continuous and of course non-differentiable. Okay, so I'll just remove all these things for you, so you can just simply have a look at this. Very important, sir. Very important. Simple but important. Differentiability in an interval. Again, what are you gonna do, sir? We have for open interval. This is for closed interval, bacha. A comma b. Fx is said to be differentiable in interval a comma b when what happens? When happens what, bacha? First thing is, you have some points, remember all three, sir. First point, fx is differentiable at x equals to a from right side. Why from right side, bacha? Same condition, no? From here, sir. So this RHD should exist at point A, no? RHD should exist, and point B, bacha, what will happen? Your LHD, left hand derivative, should be also existing at point B. At point B, you should be having from left side, means your LHD should be existing at the point B. Okay, finitely, what means it should be equal to a finite number. Okay, and fx is differentiable at all the points. Okay, both sides at every point between the A and, means between A and B. All these points are there, no? All these points, it should be differentiable at all the points. Means LHD and RHD should be equal at all these points. That's how you define differentiability, right? So at every point between A and B, it should be differentiable at all the points. Basically, at every point, the LHD should be equal to RHD, and at the point A, only the RHD should exist, and at the point B, only the LHD should exist, because there's no point after the point B, right? That's a part of domain, right? Okay. A function fx is said to be differentiable in an open interval for only this bacha, this condition, right? This part, this 3 and this is same thing, okay? Should be differentiable at all the points between A and B, okay? This 3 and this is bacha same thing. All right, let me just erase this part for you, and then we'll move on to some general theorem on differentiation. Now from here, the question keeps coming in examination. So from the first, that what we have learned so far, no, 2 questions can come. One question on continuity, one question on differentiability. That is that can come. They can give you one more on continuity as well, but maybe 2 to 3 questions can come from the concept that we have learned so far in your KCET. 2-3 questions, okay? One on continuity definition, one on differentiability definition, okay? Now the question will come from differentiation of implicit function of parametric form. So there are a lot of questions over here. From second order derivative, questions will be coming here. So please check. So first rule that we have over here, sir, one more thing that we should know quickly. For any constant, sir, differentiation is 0. For any constant, the differentiation is 0. If you multiplied a constant to a differentiation, you can just take it out. You can take it out from the function. Constant can be taken out, sir. As we did in the limit, right? We can take constant over here also out. Product rule, sir. What we do over here, whenever we have 2 functions in product and we are asked to differentiate that, what you do is you keep first function differentiation. So you keep the first function as it is, differentiate the second one. Okay, over here, bacha, you differentiate the first one and keep this as it is. Preference does not matter over here. In case of product rule, preference does not matter. Just remember, you have to differentiate both the functions one by one. Clear? You can apply this, bacha, this rule for more than one function also. Sorry, more than 2 functions also. Over here we have only 2 functions, no? We can do it for more than 2 functions also. For example, check this out. 3 functions, fx, gx and bx. Okay, what you can do, bacha? Differentiate one by one. First you differentiated fx, kept these 2 as it is. Next, bacha, differentiated gx, kept these 2 as it is. Over here, differentiation of bx and kept these 2 as it is. Okay, so you can take any order. Okay, but remember one thing, that all the function has to be differentiated at least once. Okay, it has to be only one, not at least, only once you have to differentiate all the function. Okay, you can take for more than 3 function also, that also is okay, but they don't ask that much. Maximum they can ask till 3 functions only. Given in product, let's try to differentiate in the product rule. Okay, chaliye. Next, what we have, sir, quotient rule. What we do over here, bacha, the order, the preference matters. So what you do is differentiate the first function over here, differentiate the first function fx, and then, bacha, keep the denominator as it is. Keep this out, fx by gx, no, gx is the denominator function, keep as it is, differentiate the first function, minus sign, keep first function as it is, differentiate the second function gx. Okay, first and second one means, bacha, first means basically a numerator function, and second I am taking over here as denominator function. No, nothing like then in case of by parts. Okay, and divide this by square of gx, square of gx. Okay, chain rule, sir. Okay, what happens in chain rule, sir? Sometimes what happens, no, the function will not be directly given in terms of variable that you're looking to find the differentiation in. For example, check here, I have u in terms of gx, okay, and you want to find, bacha, dy by dx. So y is in terms of u, so we have y in terms of u, and we have, bacha, u in terms of x. And what we're looking for? We're looking for, bacha, dy by dx, sir. So what we do? We differentiate y with terms of u first. We differentiate y with terms of u first, and then, bacha, what we do? Differentiate u with terms of x. That's called as chain rule. It's called as chain rule. Please check over here. Y with u first, then u with x. I can do with more than 2 variables also. y with u, u with v, v with x. Okay, v with x. Chaliye. So have a look. This is clear, right? Now sir, I have taken one question over here. Let's solve this quickly. What is there? X square plus sine y plus y square plus log of x plus y. Then find dy by dx. Differentiate, sir. Two y, correct, plus bacha will have here 1 upon x plus y, okay, times of 1 plus dy by dx. Chain rule over here, right? First you did for log, then comes your for x plus y. So x is going to be 1 and for y will have dy by dx. Okay. Now they are asking us to find the value of dy by dx, right? So I have to take something common and keep it like this. So let's do one thing, bring all the terms of dy by dx at one side. Okay. So before I have that, 2x plus cos y dy by dx, 2y dy by dx plus 1 upon x plus y, and we have also again plus dy by dx times of 1 upon x plus y. Okay, let's do one thing, bring everything on one side. Okay, so I'll bring this thing over here and this thing over this side. It'll become bacha 2x minus 1 upon x plus y. Okay, and we'll have over here 2y dy by dx plus dy by dx 1 upon x plus y. Okay, and I will have a minus cos y dy by dx. Okay, chaliye. Again I take something common over here, I can do that. It will become bacha x plus y 2 times of x plus y minus 1 equals to, I can take here sir dy by dx common. It will become bacha 2y plus 1 upon x plus y minus cos y. Right? Can I simplify this? It will become bacha, it will become sir dy by dx. Okay, the LCM will be x plus y only, right? So x plus y. Here will become 2y times of x plus y. Okay, plus 1 minus cos y times of x plus y. Okay, right? So you can check over here. What I can do is basically, okay, I'll write the final answer on this side. So I can check this and this is cancelled, right? Have a look. This part here is cancelled, sir, with this part. Correct, no? I can write it over here and write this. Check this out. 2 times of x plus y minus 1, no? And over here same thing I have. So x plus y, right? I can cancel over here only. Don't try cancel on this point. Cancel. 1 second. Over here only, sir. This is cancelled. What I'm getting now? So I'm getting the final answer. I can write on this side. Dy by dx equals to, check this out, what I'm going to get? This value, 2x times of x plus y minus 1 divided by this whole thing, bacha, 2y times of x plus y plus 1, and then the other thing, I have, sir, x plus y times of cos y with the minus sign, right? So write here minus sign. That's your answer. This is a fraction, okay? This is a fraction, sir. Please check your answer. Okay, good. 2x times of x plus y minus 1 divided by 2y times of x plus y plus 1 minus x plus y times of cos y. Done. Okay, let's move on to next part. I hope this is clear. Have a look. All right. So next we have differentiation formulas that we have for different functions. So for ITF, which is there, but I have not written for all the functions sin x cos x. That is very simple. Do one thing. I have already made a formula sheet for you multiple occasions in KCET series. Go ahead, check it out. I have made that in the Brahma series also. Go ahead, check the Brahma series session for your formula for differentiation. Okay. So I have just mentioned some formulas over here from the ITF. Okay, for sine inverse what we have, bacha, 1 upon 1 minus x square. For cos inverse what I have, sir, minus 1 upon 1 or minus x square. Only the difference is minus 1 over here. Okay, for tan inverse what I have, bacha, 1 upon 1 plus x square. And these are usually not used, but you can remember this as well. Okay, don't miss, don't keep it to a chance whether it comes or not. Just remember all the 6 formulas. Okay, for log and as well already. Okay, what is log formula, sir? 1 by x, right? And for exponential also, okay. We'll see whenever it comes to the question, we'll solve that right there only. Okay. not a problem. So please, I'm not giving you the formula sheet over here. For formula, I have already given that in Brahma series. Go ahead, check it out, the formulas of differentiation. Okay. Some properties bacha of logarithms. Why I'm giving you here? Because in case of implicit functions, in the case of implicit function, we are using this at multiple occasions. So again, I'm not explaining you. Just go through it. It's just mentioned over here for your help. Not explaining you this part. Okay. The formula for product, for we have for quotient. Okay. For the base change. All right. Yes. Then we have, sir, exponential function with log becomes simply x. Check this out. So go through this. Right. Next, sir, we'll solve the question number 3 quickly. Differentiate e power log x, log 3x with respect to x. Okay. How can I differentiate it? So, sir, we'll have to apply, bacha, first of all, we have to apply over here your product rule. Let's check it out. So, y equals to e power log, right, I have, and we have bacha log x, correct, no, times of log 3x, correct, right? E bar log bacha will become simply this log x, right? So I have, sir, log x into log 3x, correct, na? Log x into log 3x. How come, sir? E and log bacha will cancel, right? That's why. Okay, so log 3x into log 3x. What are you gonna do? Differentiate it, sir. It'll become dy by dx equals to, apply the product rule over here, keep this as it is, so log x will be kept as it is. What I've got over here is, check this out, it will become log 3 differentiation, so 1 upon 3x into 3, okay. What else I have? Plus log 3x as it is, it will become 1 by x, hai na? Right? So what I have the LCM as, x is the LCM over here, what I get, log x with the 3 plus log 3x, hai na? Log x with the 3 and log 3x. What I'm getting over here, please check. I'm getting here, sir, log x cube plus log 3x divided by x. Okay, log a plus log b. It becomes such a log of a into b, right? So log x cube into 3x. 1 second. 1 second. Please check. This is 3x, right, divided by x, okay. So what I'm getting over here is log of 3x power 4, right, divided by x. Okay, so we have log 3x power 4 by x, right? Okay, but have I made some mistake? Please check. Oh yes, have a look. This is cancelled, right? So I don't have 3 over here. This is not there. Okay, so this is not there. Okay, so this is not there. Okay, so what I get? 3x square only. Yes, let me just change something. So what I've done over here, what is the mistake over here, bacha, is I have written here 3 and 3. This is cancelled, right? This 3 and 3 is cancelled, no? So I don't have 3 over here. So I'll just erase these things, extra things. So I'll erase this 3 over here. 1 second. And this is cancelled, okay, already. Let me just quickly ignore this over here, bacha. And what I get is this also is not right. This has to be 3x square, no? 3x square is correct. 3 into x is 3x square. Option should be bacha, option number B. Option number B is correct. Option number B is correct. That's good enough, no? Please check. Yes, so question number 3 is done. Let's move on to question number 4. But before that, we have something else. Let's have a look. Parametric form. Okay, let's have a look at parametric form. What we do in this, bacha, if you remember. So what we do is, we simply write this as y equals to, if I have a function given like this, y, in terms of a parameter, let's say function of theta, okay. We also have, bacha, let's say x in terms of another function, bacha, theta or g of theta we have. Okay, then what we do is, and they're asking us to find dy by dx, okay. So what we do is here, bacha, we find dy by d theta divided by dx by d theta. Okay, similar thing we have done in case of chain rule also, but over here we take the ratio of that. Okay, when we do that, what we're gonna get, bacha, f of theta by, basically what we're gonna get, sir, f dash of theta upon over here g dash of theta, and you take the ratio, that will be your answer. Okay, so don't worry about that, just simply worry about this part. That will be more than enough. Excuse me. Okay, just worry about this part. dy by dt. So whatever function is given here, so with the parameter, so differentiate the function number 1 with the parameter what is given in, second function also with the parameter which is given in, and then take the ratio. Clear, right? Okay, Next, what we have, sir? Last concept of this chapter. What is that? Second order derivative becomes very helpful in case of AOD, where we are looking to find maximum minima, right? Second order derivative test is there. So based upon this, if you know this, then only you can solve that. Okay. I hope you know this. Yes, it's a revision, right? Please check this out. Derivative of dy by dx. Sir, why, sir? Sir, bacha, in case of dy by dx, what we used to do? In case of dy by dx, what we used to do, sir? Derivative of y with respect to x. Yes or no? In this case, what are you going to do? Derivative of the first derivative with respect to x, sir. So I'll repeat myself. Derivative of the first derivative is called as second derivative and is given by this formula, d square y, this notation, d square y upon dx square. We can also write this as y double dash y2 or f double dash x, like that. That's the way to write the second derivative. Okay, so this is how you define it. Derivative of first derivative is called as second derivative. So okay, we have a note. If the function f is defined by y equal to fx, then its first and second derivative is given like this: f dash of x, f double dash of x, dy by x, or dy by dx upon d square y upon dx square for second derivative, y1 and y2, or y dash and y double dash. Getting it? Simple enough. Just the notations, okay? Important in the questions, that's why. They'll simply ask you with the notation. You have to understand what they're asking, okay? Now let's have a look at the question number 4, okay? We quickly wrap this up. What they're asking. dy by dx is given, bacha, again on the parametric form. How can we do this question? Have a look. So we'll solve this first. dy by dm will solve, bacha. And we'll also have to solve dx by dm, no? Okay, and to find this value, what is it? dy by dx will differentiate that. The ratio will take in the, like this, dx by dm. Okay, let's find this, bacha, first one. dy by dm will find. Where is it, sir? Over here. Check this out. So it will become, bacha, first of all, constant is 1 by 2 kept outside. 1 by 2 is a constant kept outside as it is, okay? No change to the constant. Next, differentiate e power m will become, bacha, e power m as it is. And what we'll have? Plus. It will remain, sir, e power minus m, but differentiate minus m, no? For the chain rule, it will become minus 1. I'll repeat myself. For e power m will remain e power m. For e power minus m will remain e power minus m, the differentiation of exponential function. But for chain rule, bacha, minus m will become minus 1. Here m becomes 1, that's why I'm not writing it. But minus m becomes minus 1, that's why I have to write it, okay? So now what this is going to be? Please check. It will become e power m minus e power minus m divided by 2. And how much is that? X. So write this equals to x. So what we are getting, sir? dy by dm is equals to actually x. Is that clear? Okay. Next, sir, let's do dx by dm. Let's do dx by dm, this part. Okay. dx by dm. So what we're gonna do? Constant is 1 by 2, no? So let's keep it outside constant. Now do for em, sir, it will remain em as it is. Minus sign is as it is. E power minus m will remain as it is. We'll have for minus m minus 1. Okay. For minus m will become minus 1 differentiation from chain rule. What we have over here is e power m plus this minus and this minus become plus, so e power minus m by 2. Okay. dx by dm. We are looking for dy by dx. Please check from here. Okay. Will become, so dy by dx becomes equals to dy by dm upon dx by dm, which is nothing but, have a look, this is x, sir. dy by dm is, sir, x. What about this, bacha? This is y. Have a look. E power m plus e power minus m by 2 is y. So x y y. X y y, sir. It is x y y, bacha. This is your answer. Please have a look. I hope this is clear. Have a look. Question number 4 is done. We'll solve, sir, the last question of the day and we'll complete the session also. Yes, I have revised you all the simple concept which is there in this chapter. And as I'm saying, chapter is not difficult. It's just, having more weightage. Good for us, right? So just solve these questions. If you want to solve the PYQs, bacha, go ahead, check the KPL for continuity and differentiability. I've done PYQs there. So please go ahead and check it out, okay? And again, we'll solve more questions in the live sessions as well, okay? So let's solve, bacha, question number 5 now. What we have? Differentiate this function with respect to this function. Okay, so basically let's call this, bacha, y equals to, I'll call, or let's call this with a different variable. Okay, I already have, no, so I'll call this, sir, u, let's say. So u equals to, I'll call cos inverse of sin x, and so v, I'll call it as tan inverse of x. Okay, what are they asking, bacha? They're asking, sir, du by dv. And how do you find that? So du by dx you find, and divided by dv by dx. dv by dx, correct? No? So let's do it, sir. First part, du by dx. Okay, what happens? Cos inverse, right? I taught you the formula in the beginning, explained you. So minus 1 upon root of 1 minus x square, right? What is x over here in place of x, sir? Sine only, right? So right here, sine square x. Sine square x, bacha, right? Instead of theta, what we have, sir? We have x, no? Sine x, right? So it will become sine square x, okay? Check this out, it will become, one more thing, I have to do the chain rule, right? That's not enough. I have to do the chain rule also. Excuse me. I'll show you how. So once you differentiate this part, cos inverse is differentiated. This is, sir, derivative of cos inverse. This part is derivative of cos inverse. What about sin x, sir? It will become cos x. It will become cos x. Agreed? So cos inverse, it is minus 1 upon root of 1 minus x sin square x. What about sin x, sir? It will become cos x. Okay, let's continue from here. What I have, minus 1 upon, it will become, sir, cos x. How come, sir? 1 minus sin square, bacha. 1 minus sin square is cos square, no? Root will become cos x into cos x. Cancel, cancel. What I get? Simply minus 1 as your du by dx, sir. Okay, this is clear. This is coming as minus 1. I hope this is clear. Okay, next, bacha, we'll do dv by dx. dv by dx, let's do it. dv by dx, sir, will become derivative of tan inverse of x. Simple, sir. 1 upon 1 plus x square. Now let's find this value. du by dv, sorry. Okay, what I get? Minus 1 upon 1 plus x square. The whole thing will go up. It will become minus 1 times of 1 plus x square. Okay, how much is that? Answer is option number C, sir. Option number C. Please check. Okay, so I hope this is clear. I hope this question is making sense to you. Let's have a look one more time. Okay, so with this, bacha, I'm going to end the session now. Okay, I hope you had fun. I hope I was able to revise you, help you in the revision of your chapter C and D. Okay, so let me know your comments, your feedback in the comment section. Okay, again, I'll be back with another session in your Masterstroke. Till then, take care of yourself, keep working hard. Bye-bye.